Part 4, Competency 12. In this video, we will work with similar 3D figures. Number 1, the ratio of the volumes of two similar rectangular prisms is 8 to 27. If the surface area of the smaller figure is 48 square inches, what is the surface area of the larger figure? Okay, the first thing is that we notice we have a ratio related to volume, but our answer is related to area. So we need to change the scale factor ratio that's given to us, okay? So what do we need to do? So we can put 8 over 27 underneath that cubed root. Okay, I see what it needs to be. Okay, I see that I have 2 to the third power and 3 to the third power, and then I need to take that 2 and 3. But let me show you what to do if you don't see it. Okay, push alpha window, okay, and look down at number 6, push number 6, okay. We want cubic, so I put 3 there, and you saw where I had to arrow over. Now 8 divided by 27, push enter, and I know that that decimal does equal 2 over 3. But again, if you haven't watched other videos with me and you don't know, what you need to do is push math, and it's set up to give us the fraction. So you push enter, enter again, and that is what we need. However, that is for a one-dimensional situation, a side or a segment. So we're going from volume to area. This means that this implies that I need 2 squared and 3 squared. Obviously, that is 4 over 9. Now, I can set up my ratio now. Okay, and I see that the smaller figure is related to 48. So I put 48 on the top. X is the larger surface area that I am looking for. Okay, so that means I need 4x equals 9 times 48. Divide both sides by 4. Cancel that out. And this is what I need to put in my calculator. Okay, 9 times the 48, divide by 4, enter, 108. Okay, now let's look at our options. I see that we only have one 108, okay? But I want to draw your attention to option B and D. We could have marked those out in the beginning because inches like this, that is like assuming it's to the first power, and we're looking for area. So both those answers are one dimensional, so we know they aren't going to work. They do not apply. So C also doesn't. So of course A is your only option. Okay, now let's look at number 2. The ratio of the radii of, which are, let's just say 2 radii, okay, of 2 similar spheres is 6 to 1. If the volume of the larger sphere is 1,620, what is the volume of the smaller sphere? Okay. And if you didn't notice on the first one, it's also true on the second. We really don't need to know the formula. We don't need the shape. I mean, you can draw them if you wish, but it isn't necessary. What is important is that any radius, that is one dimensional. So we know that this is one dimensional. So this would be equal to just that first K value. So that's related to perimeter. But we are looking at what? Volume. Okay, so that's volume. Okay, so we will have to, and the answer are given in our answer. So we have to take our K and put that up to the third value. The third power, excuse me. So we have, oops, let me change that. So we have 6 to the third over 1 to the third equals, okay, we know 1 to the third, and if that would look like a 3, there you go. Okay, so 6, carried up, third power, push enter, there it is. 2, 1, 6, okay? All right, now, what do we need to associate where? Okay, the volume of the larger, okay, and we're looking for the smaller. So, of course, the smaller will correspond with the 1, and the larger corresponds where we had 6 to the third, or 216, okay? So we have 1, 6, 2, 0. Now, let's carry through with our algebra. Okay, 216x equals 1620. Divide both sides by our coefficient. Okay, and those become 1, and here you go. Okay, let's put that in the calculator. 1620 divide by 216 and enter. Okay, and that is actually correct. Think about it. If we're talking volume, that would be the only thing that makes sense, because if you have something that's 6 to 1 and then you cube that and then you multiply, yeah. So the smaller sphere is somewhat smaller, quite a bit smaller, okay? The height of the larger of two similar cylinders is 20 inches more than the height of the smaller cylinder. If the ratio of their surface area is 9/49, what is the height of the larger cylinder? Okay, there's a lot going on here. First thing, a ratio here, that is related to area. So we need to get just the value of k. That's k squared, okay? Now, the height of the larger of two smaller, okay, they're talking about cylinders. Cylinders does imply volume, but the height, that's one dimensional. So I'm looking at our k, and we need our k to also be one dimensional. Okay, so let's get started. Okay, and we need 20 inches more than the height. Okay, so what are we really doing here? And then we have two steps going on. Okay, so in the end, they want the area, I'm sorry, the height of the larger cylinder. Okay, so to get the height of the larger cylinder, we need 20 plus x. So right now, we'll set up our proportion and get the value of x, okay? So if I put that 9/49 under the square root, I know that I have 3/7, and that's k. That's one dimensional, which is what I need, because I know that height is what they're giving me information about, and it is also one dimensional. So for the smaller one, we're just going to call that x, and for the larger one, we're going to call it x plus the 20, okay? So now we just need to apply some algebra. So 7x equals 3 times the x plus 20. Divide both sides by the 7. Mark out 7/7 because, as you know, that equals 1. Now, that is incorrect. What am I doing? Okay, I bet some of you were screaming. What is she doing? I am so sorry. This is what we actually need to do. 7x equals the 3 times the x plus 20. Now we need to distribute. 7x equals 3x plus the 60. See, I distributed my 3 properly. Okay, now what do I need to do? Well, follow through with my algebra. Minus 3x on both sides. Okay, This cancels out. And then I have 4x equals the 60. Divide both sides by the 4. This cancels out. So what do I really have? Well, 16 divided by 4, I do believe that is 15. Okay, but you know what? You could, if you want to, just say this. You could say 20 plus 60 over 4. Remember, this ultimately, this is what we're looking for, the height of the larger. All right, so let's see what that is. So 20 plus, I'm going to use parentheses, 60 divided by the 4, and close my parentheses, push enter. 35 is the value. And remember, I said that 20 over 4, I thought it was 15. Well, 15 plus 20 is 35. So it is 35 inches. And also, notice that our answer is not squared. So that should include me in to what we were doing. Okay? All right, let's move on. Okay, number 4. The volume of the larger of two similar square pyramids is 20 inches more than the volume of the smaller pyramid. If the ratio of their areas is 16 over 25, what is the approximate volume of the larger pyramid? Okay, all right. So the answers that we're looking for are all related to volume, okay? However, the area ratio, okay, that ratio is area. That means we have, I'm looking at it, that's 4 squared and 5 squared. So we know that we need to take, okay, let's just give ourselves K here. We know, okay, because you have to put them under the square root, just like I did prior. I'm not going to waste your time with that. That means our value of K is 4 over 5. But to set up our ratio, our proportion, we need area. Okay, that's area. We need volume. Okay, so what do we need? We need 4 to the third over 5 to the third, which equals, okay, well, it'd be nice if you could read that. All right, there we go. That's better. Okay, let's see. 4 carry up 3. You see how I did that? I'll do the other one. Okay, that's 64. Now 5 carry up. Okay, 3 enter 125. Okay, now we set that equal to, let's see here, what is our 20? That is all related to the larger one. Okay, so the smaller one is our x, and x plus the 20 again. Oh, well, okay, we're using 20 again. Okay, all right, so that's how we set that up. So what do we have? We have 125 x equals 64x plus the 20. Okay, this time I'm not going to make that mistake that I did before. We cannot just divide because we have x on both sides of the equal. So we have to distribute first. 125x equals 64x. Okay, I'm not going to do that in my head, all right? So we're going to say 64 times the 20. You know, I could have, but let's not. Let's not risk it. When you get tired, it's best to just refer back to your calculator. So 1,280. Now, minus 64 on both sides. Okay, this cancels. So what does that give us? 125 minus the 64. Yes, that'll give us, yes, 61. 61x, which is equal to 1,280. Divide both sides by the 61. Okay, all right, of course, this cancels, and this is what we need to get the value of our x. Now, let's see what it's asking. Again, it's asking what is the approximate volume of the larger pyramid. This is very similar to the last one. I suppose they just wanted us to practice. Okay, so what do we really need to do? We need the volume of the larger one, and that will equal 20 plus 1280 over 61. Okay, and we are getting a rounded value, whatever that is. So let's put that in a calculator. So 20 plus, I'm going to use parentheses, 1280 divided by 61, close my parentheses and push enter. Okay, now let's look at our options before we do anything. Yes, and I'm sure you can see that we're going to round to 41. And okay, but what 41? Let's see, we have 61, we have 41. Looks like we may have an error. Let me check this out. Hey, sorry about that. Okay, now let's look at our answer choices, okay? So we know that it's going to be 41 when we round, right? Now let's also look at our inches squared, inches squared. Those would not have worked for several reasons, okay? The first thing that would include me in was the value of 61, as well as that the answer was inches squared. Now we know that it's C because that will be to the third power. And of course, D is way too small. We can already see that because it's 20 plus more. Okay. So we could have probably figured that out as long as that little error wasn't there. I apologize for that. It was a quick fix. Okay. This is the last question in this video. And once again, even with my errors, I am so sorry, but you can see what not to do. And obvious mistakes I make when I'm tired. Okay, which is why we have our calculator to help us when we are tired during a test. Okay, don't forget to like us, share us, and please subscribe. It would really help out as far as getting more of these free items to you. We have a lot planned, and the more subscriptions we have, the more we can put up for you. Okay, thank you and happy testing.